Hey, and welcome back to another video. So you're comfortable with Swift UI and you want to dabble into a bit of UI kit and you're wondering, how can I get started? Or maybe you're someone who just needs a UI kit refresher, or you just want to learn UI kit to help you land your next role or your first iOS role. Well, in this video, it's basically going to be a bit of a crash course with UI kit in terms of what you need to know in order to get started with building UI kit applications. And what we're going to do is build this application here where we're fetching data from a service and putting it in a list. So we're going to actually learn about, what is UI kit, the differences between UI kit, Swift UI, auto layout, common design patterns, and a lot more to help you achieve this application. So by the end of this video, you should know the core principles needed to work in a UI kit code base. Now you can actually find all of the source code on my GitHub too if you want to see the final result. So without further ado, let's get started. So you may have even never heard of what UIKit is, but what is, UIKit? Well, UIKit is a framework that was released in 2008. So yeah, it's been around for a nice amount of time. And what it allows us to do is essentially build UI components on the screen that apps use to interact with framework services or whatever that may be. So you may be wondering next that, okay, what's the difference between UIKit and Swift UI? Well, they both allow us to achieve the same thing, which is build iOS applications. But there actually is a difference between the two, and that difference is when it comes to how we basically, build our UI and manage our data state. So Swift UI is a declarative framework, meaning that when you tell your app what it should look like and do depending on some state, an example of this is if we actually look at this code block, you'll see that we actually define our UI on the screen and then it reacts to some kind of state changing, so we get something new, which is why you may see the term thrown around called DSL, which actually means declarative syntax language. Now this is one of those acronyms, kind of like when you see MUA and you don't know what it means, and then you finally find out that, hey, it means a makeup artist. This is a similar thing. So DSL just means declarative syntax language, but UIKit is not declarative. Instead, it is imperative. So imperative programming doesn't really manage state like SwiftUI does. Instead, it just tells the program a set of instructions that it must execute and handle. And this control flow, meaning that you have to manage the state yourself. So let's say in SwiftUI, you have a list that basically listens to an array and updates. In UIKit, you actually don't have a state to bind to. Instead, you have to basically tell the system the steps and then force a refresh yourself since it doesn't manage state. So now that we've actually covered the, context and the backstory, we've gone through all the theory, we're now going to dig into the hard part. So this is the part that we want to get into. So I'm going to basically create a brand new UIKit project, and I'm going to start off just walking you through the steps to get you from A to B. Let's get straight into it. So what we're doing now is we're just going to create a brand new project in UIKit. So you want to create a brand new project, as you can see here, and you want to make sure that you're not selecting, for this tutorial anyway, you want to make sure that you're not selecting multi-platform, as well as making sure that you've got app selected too. So once you have these two selected, the next thing you want to do is choose next. Now, normally you would have this selected when I do, the Swift UI tutorials as Swift UI, but this time you want to make sure that you have storyboard selected. Now for the product name, I'm just going to call this UI Kit Crash Course, and I'm not going to go into too much detail about creating a brand new project in Xcode. If you want to see more information about, what everything here means, then be sure to check out the video that I'll actually link, pointing the wrong way, pointing in the card up above, so you can check that out. So let's click next, and then you just want to save this somewhere, so you can choose where to save it. Now I'm just gonna put it in download so I can just get rid of this later. So now that you have this on your machine, we've now got our UIKit project set up. We've got everything that we need. Now in Swift UI, you'd normally get presented with the view here, but as you can see, when we create this project, we're just straight into the general project. So when you're working with UIKit, it's not the same as Swift UI. You don't have views, so none of that exists, bro. So what you have is you have a view controller. So you'll see on the left hand side here where you've got your project folder here, you have a view controller, and essentially a view controller is just a screen that you use within your UIKit project, and it also has some lifecycle functions that allow you to perform certain operations when your view loads in memory, appears, disappears, all that stuff. So views not a thing here. It's just a view controller. So within your view controllers, you can add things like UI elements, and also as well, if you wanted to, we're not going to do in this video, but you can actually add view controllers within view controllers. Inception, right? But if you actually just go to the Apple documentation, I just want to show you the life cycle of a view controller. So let's just look at that now. And you can see here on the Apple docs that you have, you know, the definition. And one thing I'd recommend, especially when you're doing iOS development, is to get used to reading the Apple documentation, because you know, pretty much all the answers for what it is that you need are, you know, listed here. But if we just scroll down, you'll see that there's actually a diagram here that basically shows you the life cycle of how a view controller, you know, enters the screen, and also as well what functions are called. So this is something that you might definitely want to check out in the documentation to make sure that you call your code in the right stage for what, you know, your view controller is in. So let's just go back to our project. And when you actually create a project for the first time, if we actually just run this on the simulator, so I'm just going to choose, you know, let's pretend I've got a brand new phone, man. Why not? Let's say we've got an iPhone 14. So I'm just going to choose iPhone 14. Let's run this. So you can see here that our app has loaded now in the simulator. So this app right now is using a storyboard. So the storyboard is essentially just a file where you can basically drag and drop elements to basically view onto the screen. So just to show you a quick example of that, if I want to add a button onto the screen here, what I could do is I could hit the plus button here, and I can just drag a button onto the screen and put that there. And if I just run my app again, you'll see that we now have a button on our UI. So you can basically quickly build up UIs by using a storyboard. Now, for this tutorial, we're not actually going to be using storyboards because I'm not a personal fan of them. And the first reason why I'm not a fan of them is because they actually do increase the size of your project overall. You know what I mean? And the next problem that I have with them as well is that they're not really dynamic and configurable, because you can basically you might be in a situation where you need to swap out UI in between, you know, different states and whatnot, and you don't want to have a overloaded storyboard with a bunch of screens and a bunch of UIs, and it just gets really messy. So for this tutorial, we're actually going to use a programmatic layout approach. So the storyboard here, sorry bro, you gotta go. So what we're going to do is go to our project structure, and then here we're just going to delete this main file. So that's going to delete the storyboard file and then move to trash. Now, deleting the file isn't the end of it. What you actually need to do as well is actually find references to that main, you know, storyboard file and delete it, or else the application that you're building will crash. Quick way to do this so you don't miss any of this is just by simply going to the search here and then just searching for main, and you can see that it's used in a few places. Now this at main, we don't really want to delete that because it has nothing to do with our storyboard, but this plist file, well, plist file entry here, we want to delete that because we don't have a storyboard name anymore. And also as well, in our build settings, we also want to remove that as well if it's still there. So I'm just going to search for main, and you can see here that we have a UIKit main storyboard file name. So let's delete that. So I'm just going to hit the delete on my keyboard, and that'll remove that. So there's no more references to main within the project. So this is what we want. So now that we've managed to do that, the next thing we need to do is actually set this up programmatically ourselves. Now you might be wondering, how do we do that? Well, if you look at your project folder structure, you'll see that you have two delegate files here, and you have an app delegate and a scene delegate. So what are these two files? So if we just click into the app delegate, so an app delegate is basically the place where it allows you to respond to app level events. So what do I mean by that? Well, let's say, for example, if your application was opened up via a push notification, or you open it from the background, or you have some kind of like background running task, all your logic for that should go into the app delegate. So anything to do with laying out screens that you show when your app launches, it shouldn't be in the app delegate. This should only handle app level events. Now the alternate, like I said before, is the scene delegate, and the scene delegate essentially allows you to basically set up the scenes, or I should say the screens, that you see within your application. So the best way to think about it is, like, let's say you go to a theater, right? Like when you go and watch, I don't know, Charlie and the Chocolate Factory at the theater. I don't know why I said that. I just like it anyway. But let's say you go and watch that, right? The app delegate is essentially the stuff that's going on in the background. So these are all the people that are doing the costume changes and whatnot. And the scene delegate is what you actually see on stage, what's presented to you. So just keep that in mind with a little analogy as well. And maybe now you'll go off and watch Charlie and the Chocolate Factory. Oh man. There's a word within the app and the scene names called delegate, and you might be wondering, what does that mean? Well, delegate is essentially you just basically telling something that I want you to do this. So both of them have delegate functions that you can implement, and they delegate to you whenever an event occurs. So you can see in the app delegate you have did finish launching with options, which basically tells you when the application has finished launching. And if you go into the scene delegate, you'll see here as well that we have a will connect to. So this will tell us when our scene is about to be connected onto the screen. So if you've ever watched one of my previous videos where I talk about delegates and you ever wondered like, what is this brother talking about? Well, now you know. So it's essentially you just basically delegating a task to some kind of object, or so you can run some kind of event. Now one thing you'll realize as well is that we don't actually have a preview here as well. So instead you have to run this every time onto the simulator, unless you use some kind of third-party tool that we're not really going to look into in this project. So the next step we need to do is actually create our view controller that we got for free in our project setup here. And we want to basically add this onto the screen now so you can see it on the screen. So within our, scene will connect to, we're going to actually write some code in here to add that view controller onto the screen. So let's just walk through this step by step so we can break down what's going on. So after our guard statement, the first thing we want to do here is we actually want to capture our window scene. So the scene is basically the area on the screen where you can add stuff onto it. So this is where we're going to grab our current, window scene, and we're basically going to add our view controller onto here with the next couple of steps we'll be doing. So after this, we actually want to set our window property here to the window scene that we got from when our application launches. So let's do that now. So we're going to say self.window is equal to UI window. And then within this window, we're now going to pass in the window scene that we got from when our screen was created and initialized. So let's do that now. Okay, cool. So one thing that you'll realize throughout this tutorial is you'll see me using the self keyword a lot. And the reason why is because when you're referring to an object of itself, it's a lot clearer to say self dot, in my opinion. Now, some people don't like doing self dot because they think it's just unnecessary, but I personally, prefer doing it. If you don't want to do dot self throughout this tutorial, what you can do is just to literally just take that out and just say window is equal to, and that's just as valid. But for this tutorial, I'm going to be using self, so right. So after this, the next thing we're going to do is create our view controller. So if you're wondering where this view controller came from, when we created our project initially, we actually got a view controller here for free. So this is where that comes from. And this is our view controller that you'll see we're going to add onto the screen that you see here. Now back to our scene delegate. The next thing we're going to do is actually put our view controller within a UI navigation controller. So when you're working with UIKit, normally in Swift UI, you would just have a navigation view, or if you're working with iOS 16 and above now, you'd have a navigation stack. But that doesn't exist here. So what you need to do is create something called a UI navigation controller, and that's where you're going to basically put your view inside of as a container, and you can add stuff like titles and buttons within a nav bar and all that kind of stuff. So let's do that now. And you can see that you have an option here when you create a UI navigation controller to pass in a view controller. So let's just pass that in. Cool. So after we finish doing that, and we've now got our view controller and our container that's going to hold our view controller with a title, the next thing we need to do is actually set the root view controller for our window. Okay, cool. So this is going to set the root view controller that you see for the first time when you launch your application. So let's say you have some logic here where you want to switch between like a login screen or the main app, depending on whether someone's logged in. This is the place as to where you would set this property so you can do that. Now, after this, we just simply need to tell the application to actually make our window visible so you can see it on the screen. So let's say window dot key, make key and visible like so. So what I want to do now is I actually want to rename this view controller here because in my opinion, it's not really a clear, name. It's kind of like when you create a new SwiftUI project and you just have content view, like what does that actually mean? So based on our video before with what we're going to be building, we're just showing a list of people. Let's just call this people view controller. And we can do that quite easily by just selecting the type and then going to refactor and then rename, and then now we'll get all the options as to where this will be renamed within the project. So I'm just going to hit plus here so everything gets renamed, and at the start here we're just going to say people view controller. So this again is something that comes down to preference. Some people don't like using the whole word people view controller. I personally do. And some people just like doing people VC to shorten it up, but I just prefer people view controller. So when you're doing this, it literally just comes down to preference. There's no way, there's no right or wrong way. It's just how you like to style and design your view controllers naming. So we hit rename. We now have our view controller. So like I mentioned before, we do have lifecycle events, and I just want to basically print to the console, that this view controller is now on the screen, and I'm just going to print some message. So let's go into our people view controller. And you'll see that we have this function here called view did load. So this is actually one of the lifecycle events that I was mentioning before. So if you ever see a function that starts with view did or view and then something, it essentially means it's a lifecycle event within that view. Now within this view did load, I'm just going to print to the console some random message. Okay, cool. So now when our view controller gets initialized and is loaded in memory, we should see this message printed in the console. So let's test that out. So because we don't have any SwiftUI previews, we have to run this again on the simulator. And if you look at the console at the bottom here, you can see here that our message got printed out and it does say your boy is in mem. But if you look at our simulator, the screen is black. So what's going on here? Well, in our storyboard file, when we had our view controller, the background color was set on it. So we didn't really have to worry too much about, setting a background color. But when we do stuff programmatically with view controllers, you have to kind of like set everything up yourself. Like nothing kind of gets done for you for free. So what we're going to need to do now is actually set the background color of our view to the system white. Now, when I'm doing setup for view controllers, I prefer not to just overload the view did load with a whole bunch of logic. I like to actually separate out each instruction or action that I'm going to perform into their own functions. Now we're going to do that by creating a private extension. So we're just going to say private extension on people view controller. And then within here, I'm just going to create a function called setup. Okay, cool. So I marked this as a private extension because I don't want this function to be exposed outside of the view controller. This should be isolated within the view controller, and that's it. And now within my setup function, I can start to add in my, UI logic for what it is that I want to do on the screen. So what I want to do is I actually want to set the background color of this view controller to white. So how do I do that? Well, with view controllers, you actually have a view, and that view is basically a box as to where you can add UI elements into and also configure. So let's see how we can change the color now. So if I was to say self dot view, you'll see that it comes up with the property view, and it says the view that the controller manages. So when you're working with configuring properties, you're more than likely going to be editing a view. So we're going to say enter. And now if I want to change the background of this, because we're working with UIKit, we don't have modifiers. That doesn't exist in UIKit. Instead, what you have is properties and functions. Now when you want to change the color of a view, there's actually a property called a background color that allows you to change the background color of any kind of, view. So let's say dot, and you'll see that we have a whole list here of properties and functions that we can call. Now, the one that we want is background. So if I just say background color, and you can see here the view's background color. And now I can set this to white. So I can just say dot white like so. So you can see the differences here with, UIKit and SwiftUI is that you have to be more explicit by using, the properties and a lot of things that you have to set up. So in order to actually use this and actually see this in action, we now need to call this function in our view.did_load, because right now our view controller still has no concept as to what its color should be. So in order to do that, after our print statement here, we just simply need to call the setup function like so. Cool. And like I mentioned before, I didn't say self.setup because I'm not setting a property on itself. I'm just calling the function within the view controller. So let's run this and see what happens. And as you can see now, we now have our white view controller, and we also have our message here within the console. So this is looking exactly like what we wanted. So now that we've done that, the next thing I want to do and just show you so we can start to, build the foundations before we get to the example I showed you at the start is how to build UI elements on the screen. So when you're working with UI in UIKit, you'll see that a lot of them start off with the word UI. So I'd highly recommend you check out the Apple documentation because there's a whole bunch of elements that you can use in UIKit. But the first thing that I want to look at how we can add onto the screen is a button. Now we're going to do this by using lazy initialization, which I'll explain after we finish typing this out. So let's go into our view controller. And then here at the top, we're going to create a private lazy var for our button. You might be wondering, what does this mean and why have I done this like this? Well, the first reason is that I personally don't like to have a lot of UI logic within my setup functions. I like it all to be encapsulated within the closure, which helps us set up this view. And the other benefit of using this lazy variable that we initialize is that, let's say we're in a situation where we need to switch between two different, views. Because it's lazy, until we actually call that, call the name subscribe button within a function, it actually won't initialize and use this view as well. So it can also help you out with performance. Now this is complaining because within our closure, we don't actually create a button. So within here, we're going to create a button using the new UI button configuration API. So prior to that, there is an old way of creating buttons, but we're going to use the new API because it just helps us speed up a lot of things. So let's do that now. So within here, the first thing we want to do is actually create our configuration by using the new configuration API for buttons. I'm just going to call this config. And then we're going to say here UI button.configuration. And you'll see that when you create this, you actually get some default methods that actually come for free. Now, the one that I want to use is filled. So we're going to use that one as a, baseline. And then after this, we're actually going to change and configure our config. So we're just going to say config. Now I want to set the title. So you can see here, when you want to set a title, there's a property called title. And we can just say here, subscribe. And then if I want to set a background color, we can just say config.base background color. And then I can just say here that I want this to be red because I want it to match like the YouTube subscribe red. I can also change the color of the text as well by saying the base foreground color and set this to white like so. And I don't need to give this button a default, like a hard size. I can actually just use the configuration to use some default sizing for me. So I'm going to say that I want the size of this to be large because I want a big button. And then finally, I like my rounded corners. So we've got to put some rounded corners on this. So we're going to set the corner style to be of medium. Cool. So now that we have our config, the next thing we need to do is actually create our button and then return that within this closure. So I'm going to say UI button. And when you create an instance of UI button, you'll see that there's an option here where you can actually pass in a configuration. So let's use that one now. And then in our configuration, we're just going to say config. And then we're simply just going to return that button like so. Cool. So now when you build the project, you should see that your error goes away and it succeeds. So we now have our button defined here at the top. Okay, cool. So now that we have our button defined here, how would we actually add this button onto the screen? Because in Swift UI, you would just declare a button, within a V stack or a H stack, and it would just appear on the screen, right? But how do we do something like that in UIKit? Well, if we wanted to do that, we have to actually add the view specifically onto the screen. And we can do this by using a function on our view controller view called add subview. So let's look into that now. So if we scroll down, so what I like to do in my setup functions is after doing any kind of general view controller configuration, I'll then start to write the logic for the auto layout. So let's add that in here. So let's just run this and just say self.view.add subview. And then what we're going to pass in here is our button that we just created. So this is going to be subscribe button. Now, in order for you to see this on the screen, we're going to need to run this on the simulator. So let's run this. And you should see in the top left-hand corner that you actually have a button on the screen here. But how do we position this where we want it to be? So let's say if I wanted this to be in the center of the screen, how would I do that? And we would do that by using something called auto layout. So auto layout essentially allows us to define constraints for our view in terms of where it is positioned on the screen. So this is basically a set of like constraints, if you've heard that word before, and rules in terms of how and where it should be. Now, when you're working with auto layout, there's a few, terms in terms of position that you need to be aware of. And that's, top, leading, trailing, bottom, center X and center Y, and these are the main foundations in terms of how you lay out UI on the screen. So in this example, what we're looking at here, what I want to do is actually just center this button in the middle of the view. So we're going to have to actually add some constraints for the center X and the center Y to get it in the middle. So after our view has been added, the next thing we want to do here is say ns layout constraint.activate. And you'll see here that this actually takes in an array of constraints. You can apply multiple constraints and activate them at the same time. So we're just going to say enter. And then within here, we want to say that we want our button to be in the center Y of our view controller. So we can type that out by saying subscribe button dot center Y. And then we're going to say dot, and you'll see that you have a whole bunch of constraints that you could use to basically put things on the screen. So you have things like equal to, where it's a specific value. You have less than or greater than. But an example that we just want equal to, because we don't really want to offset it. We just want to say just be in the middle. So we're going to say equal to, and here we're going to say view dot center Y. So this is going to put our button in the center Y of the screen. Now for the x-axis, we just want to do the exact same, but this time we want it to be center, X. So let's say subscribe button dot center X anchor dot constrained equal to view dot center X, like so. So now we're basically just positioning this in the center of our screen. So let's just run this and see what happens. So if we just run this now, you'll now see that our button still isn't on the center. So what in the world is going on? Well, basically, this is the bane of every single UIKit developer's life, and that is setting the translate auto resizing mask to false. So when you're working with UI programmatically, you don't get this for free, and you actually have to turn this off yourself. So this is what will allow your constraints to take effect. And if you don't add this in, then this is what's going to happen. It won't be positioned on the screen. So on our button, we just simply to say translate auto resizing mask into constraints. And then we're just going to set that to false to basically turn this off. And if we run this, you'll now see that we have our button in the middle of the screen. So when you're working with UIKit and you're laying out, views in the center of the screen, it's really important that you set this to false. So just keep that in mind. Because when you're working with storyboards, you do get this for free, but with programmatically, you got to do it yourself. Cool. So now that we have our button on the screen, what I want you to do is I want you to actually basically just play around with those constraints and just see how you can basically position things on different positions on the screen as well, after the video. Now, the next thing I want to do is actually talk about how you can add an action to a button. So right now we have a button, but when you tap on it, it doesn't really, do anything. So how can we, turn this and add an action onto it? Well, when you're working with UIKit, especially with the UI button configuration, there is a new closure handler that you can use to essentially allow you to add actions to a button quite quickly. But what I'm going to do is actually show you the old-fashioned way of doing it, or I shouldn't say old-fashioned, the traditional way of doing it, so that when you look at this, it's not uncommon. So let's look at how we can do that now. So if you want to do this, what you actually have to use is something called a target. So on our button, we need to add a target so that we can listen to some kind of event when it occurs. So let's go onto our button. And we're going to say button dot add target. And we want this option here that has a target, action, and 4. So let's hit enter. Now, when you're adding a target, you want it to be onto itself. So itself being the view control that you're within. So you just want to say here, self, like so. And then when we create our action, we want this to be a function name that we can use. And in this function, that's what's going to get triggered whenever our button is tapped. So when you're naming actions for your, buttons and elements, you normally want it to be descriptive. So for example, with this button, you got to tap on it, right? So we want it to be something like did tap subscribe. So let's do that now. So the first thing you want to do is do a hashtag, and then you want to type out the word selector, and then within this parenthesis, this is where you're going to put your function name. So we're going to say did tap subscribe, like so. Cool. And within the 4, you actually have, actions that you can listen to. So you can see here, there's a whole bunch of events that you can listen to for when your button is tapped. The one that we want is one called touch up inside, like so. All right, cool. So we've done that, but we still have an issue within our projects. And that's because we've not actually implemented our function for our selector, which is what this is complaining about. It's saying it can't find the function. So we need to define our did tap subscribe function within our extension here. So here, I'm just going to say at Objective-C. And the reason why you need to write at Objective-C is because it's still using an Objective-C selector. And then we're going to say function. And then we're going to just define the same name as our selector. So we're just going to say did tap subscribe. So this needs to be spelled the exact same way. So you don't even make mistakes. You should, what I should have done is just copy it and paste it. So we can just copy it and just paste it to make sure that we spell it the same. And then we're going to create our parentheses and then close that off. And then within here, we're going to say sender UI button. So within this sender, this is basically the type of, the UI control that you're basically receiving the event from. So that's here. So now within here, what I'm going to do is just add a simple print statement to just literally just print to the console. So we're going to say print. And I'm just going to say, I'm subscribing. Okay, cool. So now let's just run this and we'll just see what happens. And we get our print message to say that it's in memory. And if I now tap on this button, you'll see that I actually get an action and it responds to the action, printing out the I am subscribing. I'm hoping that you're starting to see a bit of a pattern here with UIKit, where essentially you're basically just calling instructions and telling the program to execute this instruction. So that's just literally the difference between this and Swift UI. It's a lot more explicit when you're working with it. So now that we've got the basics out of the way, 9 times out of 10 when you're working with a UI kit app, you're going to have to build components similar to how in Swift UI you can have a bunch of components on the screen. But when you're working with UIKit, you have to actually, add multiple UI elements and use auto layout to combine them to make them look like whatever you've been given by a designer, right? So in this, what we're going to do now is actually look at how we can build our component so we can see how they all come together by using auto layout and some other, UI elements that we've not covered yet. So when you want to add a component and build it, 9 times out of 10, you're going to use a UI view. And a UI view is essentially just an empty view that you can use a container to group other elements together. So what we're going to do now is actually create a UI view in here and then see how we can use it as our container for all of our other UI elements. So let's just scroll to the top here. And we're just going to create a UI view called person container. Okay, cool. So we just got our UI view here, and you can see that we just created it here as, UI view, the UI element that we want. We set a background color on it, and we make sure that we turn this off, and then we return our UI view. Perfect. So the next we want to do, we looked at our example from before, is we actually want to make sure that we can have our name and our email. So I'm actually going to create 2 new labels here as well. So let's do that now. Now, in order to create a label, it's actually a UI element called a UI label. So let's set this up. So as you can see here, we have our UI labels and we've turned this off and we've set our text to be Billy Bob. So this is how we set the text on the label. So for now, it's just hard coded, but later on we'll pass data in to load this. And then we set our fonts as well using the properties. Okay, cool. So now that we have all of our UI elements available to us, you may be thinking that, you know what, we're just gonna add all of these onto the screen and just use auto layout to position them where we want. Now we could do that, but in UIKit, there's actually a view that helps actually speed up our UI development, because adding auto layout to each and every single one of these with left, right, trailing, leading, it takes a lot of time. So instead of doing that, what we're going to do is use a stack in UIKit called Stack View. And if you work with stacks in Swift UI, you'll know how stacks help us quickly build out UI really efficiently. So let's create a UI stack view here as well as another UI element. Now, when we're creating this stack, I'm actually going to create this, with you. So we'll type this one out together. So let's say private lazy var. I'm just going to call this person stack view. Cool. And then within our stack view, we're just going to create our stack view. And then we want to make sure that we turn the auto resizing mask and set that to false. Cool. And now with the stack view, you can basically have 2 directions that you want to go to. You can have horizontal, you can have vertical. Now in our case, we want ours to be vertical. So in order to do that, we need to set our axes to be vertical like so. And then you can also specify the spacing between each element on the screen. So I actually want the spacing in our case to be 8. So we're just going to say view.spacing. And we're just going to set this simply to 8. Cool. Now, finally, we're going to return our view like so. Sweet. Okay, cool. So now we have all of our UI elements, defined within our view controller. The next thing we need to do is actually combine them and add them onto the screen. So in order to do that, if we just scroll down here, we're going to need to change our setup and our constraints, because now things are a bit different. So we don't just want to explicitly add our button and set only the constraints on our button to our view. We actually want to add our container, which is our UI view. And then within that, we're going to add our stack view. And then within our stack view, we're going to add our elements. So you can see here that we're kind of nesting views within one another. So let's just remove this. Well, not remove it, but let's just replace this subscribe button with our container like so. And then within our container, we're going to add our stack view. So we're going to say container.add sub view. So as you can see, you can actually add views within a view. So you're not just limited to just adding a view in a view controller. Every UI element you have that is subclasses UI view, you can actually add another view within it. So within here, we're just going to say stack view. Press the stat view like so. When you're working with a stat view, you don't use the add sub view like you do in terms of adding a view, because with stack views, they actually lay out the views for you. So there's actually a function in stat view called add arranged sub view that lets you add a view within a stat view. So let's use that now. Now, the first we want to have in our stat view is obviously our name label. And then after that, we want to have our email. And then after that, finally, we want to add our button. Cool. So now we have all of our views added in the right places. So we need to now add some auto layout to our, views so that it looks all good. Now, when you're working with stat views, because they automatically increase in height, depending on how many elements that you add in, we don't need to set an explicit height on the stat view. In actuality, all we kind of need to do is add a constraint onto our person container and our stat view within the container itself. So let's just do the container one first. So I just want the container to be in the center of the screen. So rather than this being subscribe button here, we're going to replace this with person container view. And then after our person container view, I want the stat view to basically grow in size, and basically this container to just be like a wrapper around the height of the stat view. So in order to do that, what we're going to do is basically pin our stat view to the top, leading, trailing, and bottom of our container. So all our container is just a wrapper around it. Now you might be wondering, why have I even got the container in the first place if we're just gonna just do that anyway? Well, when you're working with stat views, you can't actually apply a background onto them. So you have to have some kind of wrapper around them, which is why we have this container. So let's do this now. So we're just gonna say the stack view. And then we're just going to repeat this for all of them. And I'm going to say leading. And then trailing. So this is just essentially just pinning it to all the sides of the container that it's within. So let's just run this and see what we see on the screen. Cool. And now we can see our container, which is looking pretty good. So you can see here that the container is quite small, and that's because it's only taking on the size of the elements within it. So what I actually want this to do is I actually want this to fill the screen, and I want it to have some space on the left and right side. So rather than having this center X, I'm actually going to change our container to be pinned to the left and trailing of our view. So let's just tweak this a bit. So leading. And then we want this to be trailing. So if we just run this again now, you'll see that it now fills the width of the whole screen. So what we want to do next is that this is quite tight in terms of the spacing. So if I wanted to, what I could do is I actually could use a constant to help me add space around it, similar to how you use padding in SwiftUI. So after you set your constraint here, you'll see that there's another, parameter here called constant. So when you're working with the center, we don't want to change that because we want it to be in the middle. But with leading, we want the constant here to be 8. So this is going to push it 8 from the leading edge. Now, when you're working with trailing, you actually don't want to set this to 8. And the reason why is because it's going to push it 8 away from the trailing. So what you want to do instead is actually push it the opposite way by using a negative. So -8. So this also applies to bottom as well. Let's actually change our stack view as well. So within our stack view, we actually want to add some space around the label and the button and whatnot. So for our top, we're going to say a constant of 8. And for our bottom, we're going to do a similar thing to what we did with our trailing, because we don't want to push it down from the bottom. We want to push it, create some space from the bottom. So we're going to say -8, like so. And then leading, we're going to do a similar thing where we just say constant 8. And then trailing, we're going to say constant and then -8. So let's just run this and see what happens. And as you can see now, we actually do have our, space around our view. And we also have our space from the left and right hand side of our container from the view controller that is within. So when you're working with UIKit, you kind of have to visualize in your head, what the constraints would be. Or if you're using a tool like Figma or Sketch or something, you kind of have to figure out the position of where this should be. Now, one final thing I do want to do is just add a bit of a corner radius onto this container. So let's just scroll up, and on our view here, we're going to say layer dot corner radius, and we're just going to set this to be 10. So that'll give us a 10 corner radius. And now you should be able to see that you have a bit of a corner radius on your container view. So this is looking really good and close to what we had at the start of our preview. So now we have all of our UI elements, collected within this view. But if you look at our view controller, it's quite large now and has a lot of stuff that it doesn't really care about, because it shouldn't really care about, setting up all of this stuff within the view controller. So similar to what you have in SwiftUI, you want to apply a similar concept here in UIKit, where you extract out your UI into components. So what we're going to do now is actually create a component for this view, so we can just easily just add it onto the screen and use it as some kind of component. So in order to do that, you can either go to File and then New, and then New File, or hit Command N on your keyboard. And then you should see that you have these options. Now, the option that we want to use is, we don't want to use a Swift file because we have to type out a lot of stuff. We want the boilerplate code to be generated for us automatically. So we want a Cocoa Touch class instead. And if you hit next, you'll see that you have this option here called subclass of. So you can actually choose what you want your view or your class to be a subclass of. Now, in our case, we want this to be of type UI view. So we're going to say UI view. And then we're just going to call this person view, like so. And we want it to be in Swift. Hit next. And then we want this to be within our project. So you can see here our person view. So you'll see some code here that gets generated automatically. But what we want to do is we want to now start to move our UI that we have in our view controller into this view. Now, we don't want to move all of it because some of it isn't actually necessary, and I'll get onto what that is in a minute. But the first thing we'll do is we'll just basically copy over our button. So let's just cut this and we'll paste it into our person view like so. And then we're also going to want our label and our stack view. Let's paste that in as well. Cool. So you may be wondering, why did I not copy over the container view? Well, the reason being is because person view is already a UI view. So this view that we're within now is our container. So we don't need another container and create an unnecessary view for, no reason. So within this, class that we have here, we now need to move our logic that we use to lay out our UI within this person view. So one thing you'll realize is that we don't actually have an initializer. So first of all, let's just create that. And we can use the init with frame, and we're going to say super dot init and pass in the frame. So it calls that. So this is the code that will be executed when our person view is initialized. And when you create an init frame, you have to implement the required init as well. So if you're wondering what this is for, this is in the event that you use this view within a storyboard file. It'll basically, make sure that you can do your code layout here if you use this in storyboards. But it's fine that we leave this like this because we're not using it for any storyboards. We're just doing it all programmatically. So technically, only this will execute, but we just have to implement this. So we need to create our setup function within this, class. So at the bottom here, we're going to create a new private extension on person view. And then within here, we're going to have a new function called setup, similar to our UI view controller. So you can see here that, there's a bit of a pattern forming. So within our init frame here, we actually want to call our setup function. But what we also want to do within here as well is, because this is our container view, any styles that we had before on our person container view, we want to basically copy that into this setup part here. So let's go into our people view controller. And if we scroll up, we just want to copy all of this code here within our setup. And then obviously there's no reference to view here. So we're going to replace this to, self. So a quick tip is that if you just hold Option on your keyboard and Shift, you can actually drag down and actually edit all of these at once. So we don't need to do that, individually every single time. Cool. So within here, we're now going to add our code for basically adding our stack view and our button onto the screen and laying all of that out. So to speed things up, I'm going to go into our people view controller, and within our setup, I'm just going to copy our code from the person container view all the way down to here. Cool. So now this isn't, working perfectly. There are some things that we actually do need to remove. So there's no concept of person container view. So we don't want this to be person container view, because our person container view is now just person view. So we're just going to say self.add subview, and that's fine. Now, these constraints here were actually specifically related to us laying out our person view that you see on the screen here, within the center and the leading and trailing edges. So we actually don't want these constraints at all within this view. So we're going to remove this and delete it. Cool. So you'll see here as well that we still have references to person container view, and we don't want that here as well. So we want to instead just make that self, because we want our stat view to be positioned to the top, leading, trailing, and bottom of this container, which is itself. Okay, cool. So now that we've done all of that, the next thing we need to do is actually, sort out an error that we have at the top here, because in our person view, we don't actually have our action anymore that we did have in our view controller. So let's just go into our people view controller, and we'll just simply just cut this function. And we're now going to go into our person view and simply paste it within our extension like so. Cool. So within our view controller, now we can actually clean this file up and remove stuff that we don't need. So instead of us having an initializer for our person container view, we're just going to rename this to be person view like so. And then the type here isn't going to be a UI view anymore. We're actually going to specify the type here to be person view like so. Now we don't need to define any styles on this view, because we've already done all of that within our setup function within our component. So we can remove all this code here, and within our closure here, all we need to do say here is just change this to person view, and now we have a person view. So we scroll down, and rather than us adding our person container view onto the screen, instead we're going to add our person view. And we don't need all of this code because that's within the file we was in before. And we don't need this either. And now we just need to change this to now use this here. Like so. Cool. So just looking at this, briefly now, our view controller looks a lot cleaner, and it only deals with what it cares about, which is basically any kind of instructions that we'll give it. So if we was to just run this on the simulator, you should see that your view looks the exact same as it did before, except the only benefit that we have now is that our view controller isn't bloated and overloaded, which is something you want to avoid when you're working with view controllers in UIKit. So if we actually just go back into our component that we created, there's actually a bit of a flaw here. And the flaw that we have is they did tap subscribe. So right now, the logic for when this button is tapped is tied directly to this view. And that's a problem, because what about if I actually don't want to specifically only just subscribe for everything, I want to do another action? So what we kind of want to do is actually communicate from our view to our view controller so that it can perform some kind of action. And we can do that by using two methods. Now, the first method is using delegates and the second method is using closures. Now we're going to go through both of them, but in this example, we're just going to use a closure. So if you're wondering like what a closure is and how to, it's used to communicate between different views, I actually have a video where I show you how you can do that in SwiftUI, which I'll leave at the top here that you can check out. But in this example, a closure, the best way to think about it is just a inline function that you can call. So we can just call this function to trigger some kind of event. So in this file, we're going to create a void closure because we don't want to pass anything, to our view controller or return anything like that. We just want it to basically trigger an action when this button is tapped. So if you scroll to the top here, underneath your person stack view, we're just going to do a bit of typing. So we're going to say private var, and then we're just going to call this action, and then the type here is going to be of type void closure. So we're just saying here that this closure accepts nothing and it also returns nothing as well. Now, because we've created this closure, we're going to get an issue because it's not a struct, it's a class. We don't get an automatic initializer for us, so we have to create the initializer ourselves. So underneath our action, we're actually going to replace this initializer and create our own custom one using the init like so. Now in the init parameters, this is where we're going to create our, closure and actually, assign it. So after here, we're going to say action, and then we want this to be escaping. And the reason why this needs to be escaping is because we're going to call this closure outside of this block here. So we're actually going to call it all the way down here. So it needs to be escaping. And then the type here is going to be matching the signature of our closure variable. So now we need to assign it. And after we finish assigning it, we also need to set super dot init. And the frame that we're going to set here is just going to be 0 because we don't want it to have a specified height. And then after this, we're going to call our setup function. Cool. Sweet. So we actually don't need this initializer anymore because we now have our own initializer for this view. So when we built this view now, what we're basically doing with this view is an output. So when you're working with UIKit, the best way to think about it is input and output. So you want to give it some kind of data if it needs it, and it should just output some kind of data or action depending on something that's happening within the component. So now within our person view, we need to call our closure when the button is tapped. So if we scroll down here, rather than saying that I explicitly want you to print in this view that I'm subscribing, I instead just want to call this action like so. So now we can trigger some code in our view controller when the button is tapped. So we'll go into our view controller, and now within our person view here, we can just say and print IO. Right. So now let's just run this and see what happens. And now that we have our closure implemented for this view, if I was to hit subscribe, you can see it prints IO. But what about if it was in a situation where I want to call a function within this view controller? Well, let's do that. I'm going to create a function called say hello. And then within this function, we'll simply just print what we did before. And this time within our closure, we can just say self dot say hello. So we can actually call our function within this closure to perform this action. But I'm not going to go into too much detail about it in this video. But when you're working with closures, especially as a beginner, your safe bet until you learn more about Arc is just by marking the closure with the weak self. So this will make sure that you don't create any retained cycles. Now, if you do get a bug because you're disposing of this too quickly, you can investigate from there. But I would just use this as a starting point, in terms of like handling, memory leaks. So let's just see how this works now that we're actually calling a function from within our closure. So if we run this again and we hit subscribe, you can see that we get our message within our console. Sweet. So we've covered everything that we need to know in terms of, building UI and components in UIKit, because now we have this component. How will we actually hook this up to some data and display that on the screen? Well, when you're working with UIKit, 9 times out of 10, a nice starter, in my opinion, is MVVM. And I actually do have videos, explaining what MVVM is on my channel, which you can check above with the card that will be appearing. So what is MVVM? Well, MVVM in simple terms is just an architecture that stands for model, view model, and it just allows us to basically just create a separation of concerns within our iOS applications. So what we're going to do is interact with an API called a request API and use this to basically help us fetch data and display this on the screen. So let's do that now. So I've loaded up the request API here, and if we just scroll down, the one we're going to be using is this list of users that just returns a list of users to us. So we're simply just going to just use the data that we have within this array. So because of that, what we want to do now is actually create our model to represent the data that you get back from the service and put that onto the screen. So let's go into our project. And I'm going to create a new Swift file by hitting Command N, and this Swift file is just going to be called model. So if we actually just look at a JSON, and I've got a snippet on the screen here, if you just look at our JSON, you'll see that we actually do have, a structure that we need to, follow. We can't just do whatever we want. So the first thing that I like to do is that when I'm working with API responses, I like to call it the type and end it in response. So it's clear to me that this model is an API response and not just some model that I'm working with within my application. So we're going to create that now. We'll call this users response. So now within our user response, you'll see that there's a whole bunch of properties like page, per page, total pages. We don't really need these properties for the example that we're going to be working through. All we kind of care about is this data, object here that has an array of users. So let's just create a property here called data. And the type for this is going to be called person response. So let's create another struct called person response. And looking at our JSON again, the only things that we really, care about is our, email and our first name. So we don't really need this ID because we're not working with identifiable. We're just going to use a collection view, which we'll get onto in a second. So we need email, first name, and actually we do need our last name as well. So let's just add them in. So we're going to say let email, which is going to be of type string, and then the first name we're going to do some camel casing string. So we have our structs here, but in order to actually use this with our data, we need to basically make sure that they're both codable. And if you actually look at our data property as well, this type that we've defined here is actually not right. If you look at it, it's actually an array of people. So this shouldn't be a single person response. It should be an array of person response like so. Cool. So now that we've done this and we've got our model in place, the next thing we need to do is actually create our view model. So let's go here and create a new file again. And this time we'll call this people view model. So when I'm creating view models, I like it to be the purpose and just end that in view model. So in this case, we're working with a bunch of people. So people view model. And in terms of making a network request, we're going to be working with Swift concurrency, which you guessed it, I've got a course on it, which you can check out as well here. And I've also got a link in my description to my website that has a link to it. But we're going to be using URL session to basically make a call to the service using Swift concurrency. So let's first of all just define our view model. Now, when you're working with Swift UI, you'll probably notice that you add in observable object, and you don't do this unless you're working with something like Combine, which we're not, and we don't actually need that. So in our case, this view model is just going to basically be where we make our calls and manage our state ourselves. So let's create a function called get users. Cool. So now within this function, we're going to write our code to interact with that API that we just discussed before. So we're going to use the new async await syntax that we get with URL session. So when you're working with Swift UI, you would normally have the task modifier, and then you'd mark this function as async. But in UIKit, there is no concept of modifier, so you can't use that. So instead, what you need to do is actually create your own asynchronous context by using the task closure and then write your logic within there. So let's do that now. So we're just going to say here task, and then within this task block we're going to mark it and say weak self, so we don't have any retain cycles. And now you might be wondering, why am I calling it, why am I using weak self when it's not referring to anything outside the scope of this function? Well, you'll see in a minute that we do create a property for managing our state. So within here, we're now going to create our URL session. So let's do that now. So first of all, create our URL, and the string for our URL is going to just be this API endpoint. So I'm going to click on this and then copy this from here. And we're going to need to force unwrap it. And then we're going to say here, let, and then we're going to have to use a tuple where we get our data. And then mark our response with an underscore because we don't need it. I'm going to say URL session dot shared dot data. And you should see the async await version of it where it's data. It should say data and then from. And the one we want is the one where it's the URL like this. And then we're going to pass in our URL that we created on line 16. Cool. And we need to mark this with our, try and also await as well. So we're going to say try await. And because we're using a try clause, we need to use a do catch. So this will be within our do block there. And then we'll catch any errors and print them onto the screen. Cool. So now we have our URL set up. We're also basically fetching our data as well. And we're using await because we're using Swift concurrency. We try to fetch it, and any errors will print to the console. Cool. So the next thing we need to do now is actually handle our data and decode that. So we're going to create a JSON decoder. And if you actually look at the API, you'll see that some of the properties are using snake casing. So if you don't know what snake casing means, it just means that the spaces in between the words are using an underscore. So in our model, we actually find it as camel casing. So we can tell the decoder to convert this from, snake to camel case. So let's do that. And we do that by saying the key decoding strategy, and we set this to be convert from snake case like so. Cool. So now we've done that, we're now able to actually try to decode our people. So we're going to say let people is equal to JSON decoder dot decode, and then the type that we're going to pass in here is our user response because that's what matches our API response, and then data like so. And we also need to use a try here because this could fail. Cool. So we've now got our people within this constant, but we don't actually store it anywhere within this view model, so our view can listen to it and update its own state. So we're going to need to create a property at the top here of our view model called users, and then this is going to be an array of person response. So this is an empty array of people. Cool. So what we actually want to do here is, rather than storing this inside of here, we'll just, well, actually, before we do that, let's just rename this to be people. So it's just more clear. And then what we want to do is that rather than this being in a constant here, we're actually going to say self.people is equal to the decoder decoding our response from our API. Cool. So you'll see here that I'll actually be complaining that it can't, assign it, because we've got an array of person response and we're assigning a user response. And the reason why is because we need to actually access the data from our model. So we're basically accessing the array of data from our response, and now it's all good. Cool. So now we've got our view model in place to basically help us actually, fetch the data and lay that out on the screen, which we're going to get onto in a second. So the next thing we need to do is actually lay out our, data on the screen, and we can do that by using a UI collection view. Now, the way we're going to do this is the, traditional way of using the UI collection view data source, and not the new diffable data sources, which I'll basically be creating a video for pretty soon to show you how you can migrate this to UI diffable data sources. But for this, we're going to do it the traditional way. So in order for us to do that part, we're going to need to go into our view controller, and we're going to need to create a collection view. So what we're just going to do here is, rather than us having our person view, I'm actually going to remove this code because we don't really need it no more. And this can go as well, and this. And instead, what we're going to do is create our collection view. So we're going to say private lazy var CV. So if you're wondering what a UI collection view is, essentially it's just a list that you can customize into like grids and whatnot. So it's basically the equivalent of a Swift UI grid, if you ever worked with grids before. So there is something called a table view, but to be honest with you, table views are probably gonna get deprecated pretty soon, in my opinion. And that's just like the equivalent of a list. But when you're working with a list of objects, you kind of want to use a collection view for the reuse and also the customizability of it. It's really good. So within this collection view, when you're working with them, you actually have to create a layout for your collection view to tell it how it should lay out elements on the screen. When I say elements, I just mean the cells that's within the actual list. So let's create a layout for our collection view, and we can do that by using the UI collection view flow layout, like so. Cool. Now within this layout, I'm actually going to specify some, configurations for the items that you see on the screen. So you can say layout dot item size, and then we're going to say dot init. And we're going to say the width of this should be the width of the screen. So I'm basically saying that the cell should be filling the width of the screen. Now to do that, we're going to say UI screen dot main dot bounds dot width. I want the height of each one of my views to basically match the height of what you see on the screen now. Now, I don't know this off the top of my head, but what I could do is I could just use the UI debugger option here, the debug view hierarchy here at the bottom, and select this. And if I actually click on this, it'll actually tell me the height of this view. So if I click on this little triangle here, it's telling me the height is 129. So I'm just going to round that up to 130. Cool. Sweet. So now we have our layout. Because we now have our layout, we can now create our collection view. So let's say let view is equal to UI collection view. And you'll see an option where you can pass in a frame and a collection view layout, and this is the one that you want. So we're going to say frame is going to be 0, and the layout is going to be this layout that we defined. And then we need to do the usual, where we basically set this to false. And then we need to return it. Cool. Now it's really important that you set up the layout here like so. Now if you set up the layout by using the collection view flow layout delegate, which we're not going to get into in this video, then you don't really need to do this. But if you don't do this at a bare minimum, you're not going to see anything on the screen. So it's pretty important that you set this up. So now what we need to do is actually add this onto our view. So let's just add this now. I'm just going to say self.view.add subview, and it's going to be CV. And then we want to pin our collection view to the top, leading, trailing, and bottom of our view. So just going to say layout, constraints, and then activate. And then this is going to be our CV dot top anchor, constrained to the view dot top anchor, and then duplicate this. And then we'll change this to bottom. So I'm assuming you're starting to see the reason as to why some people complain about UIKit, because a lot of this is repetition and it takes a lot of time to just lay out something, to fill up this container. But to be fair, there are some, libraries and third-party tools that you can use to basically help, speed this up. But because we're just doing this a pure like vanilla UIKit way, that's why it's taking a bit longer. So if I was to now run this on the screen, we'll run this onto the simulator and see what happens. You'll see that we don't see anything. And the reason why is because, first of all, our collection view doesn't actually have any cells configured for it. So when you're setting up a UI collection view, you actually have to tell it the cells that you want it to use on the screen. Now, you're not just limited to using one type of UI collection view cell. You can actually register 10 if you wanted to and have 10 different cells depending on your data. But in our example, we're only going to be managing one type of cell. So we're going to need to create a UI collection view cell, and our UI collection view cell is what's going to be holding our person view. So let's create a new file, and we're going to call this person collection view cell. Now the subclass for this is going to be UI collection view cell. Cool. And now let's hit next, and then we'll hit create. Awesome. So it's actually created outside of here. So I'm just going to drag it in here to put it in the right place. And now we have our collection view cell. So within here, this is where we want to create the person view. So it's shown within the cell that you see on the screen. So within this file, what we want to do is we actually want to set up our person view. So I'm just going to create a property at the top here called person view. Or actually, we'll just call it view because we don't really have multiple views in this file. So I'm just going to call it view, or VW, which means view, if you didn't know. Person view. And in here, we're going to create our initializer. So this is the initializer for when our cell gets created. So when our cell gets created, we actually want to run some code to basically create our person view and then add that to the collection view cell. So we're going to say frame, and then we're going to just pass in our frame here like so. Cool. So this should complain saying we need to use the required initializer, which is fine. We'll do that because we're never going to use it, which is all good. Cool. So within here, we're going to create a function similar to what we did in our other, view called setup. And then we're going to call our setup whenever our collection view cell is initialized. Cool. So you may be wondering, why did I create a, optional property here at the top? Like, what's the purpose of this? Well, for me personally, when I'm working with collection view cells, I like to make sure that the view doesn't get created multiple times and added onto the screen. So what I want to go do here is I want to make sure that view is empty or nil before we actually create it. So we're going to use a guard statement here. And then we're simply here just going to create our, person view. So we're going to say view is equal to person view, like so. And then I prefer the syntax where it's like this with the curly braces. So we're just going to do that. And then when you're adding your view in a collection view cell or a table view cell, you want to make sure that you use the content view property and not the view property within it. So if I was to just type out self.view, you'll see that there's something here called content view, and this is the view that you use to manage the content of your collection view cell. So let's just put this inside of here. I'm going to say add the view, and we have to force unwrap it. And then now we want to add some constraints to basically pin our cell to the top, leading, trailing, and bottom of its, container, so it spans the whole, view. So we're going to say ns layout constraint to activate, and then we're going to say view dot top, and we're going to force unwrap that. And then we're going to say constrained is equal to content view dot top anchor, and we're just going to duplicate this 3 times. Okay, cool. So let's just tweak this to be bottom anchor, then leading anchor, and then trailing anchor. And then now we have it where we've added our view onto the screen. But one thing I just want to do is I actually want to add that padding that we had, the padding around the view. So I want to, space it away from the side. So in here, we're going to say constant 8. And then for the trailing, we're going to use a negative. So we're going to say, negative 8 as well, like so. Cool. So now we have our cell set up. So when you're actually communicating with a collection view cell to a view controller, like I said before, you can use a closure or a delegate. Later on, we'll look at how we can use a delegate to help us handle the action from our collection view cell to our view controller, because we don't want to put specific logic in here, because you might have a collection view cell that does multiple things and you don't want to tie that all to this view. It should be input and output, like I said before. So let's go back into our view controller. And now what we need to do is actually register that cell to our collection view. So on our view here, we're going to say register. And the option that we want is where you basically give it a class. So we're going to say here, the class is going to be person collection view cell, and it's going to be dot self, like so. Now the reuse identifier is the ID of the collection view cell. So for this, what I like to do is just make it the same name as the class name. So in here, we're just going to copy that for person collection view cell, like so. Cool. So now we have our cell registered to our collection view. Now we're not done just yet. What we actually need to do now is we actually need to set up our data source for our collection view. So when you're working with SwiftUI, you normally have it where a list is like kind of listening to some kind of state or, publish property wrapper. That doesn't exist here. So what you have to do is you have to manage that state yourself. So what we're going to do is actually create a UI collection view data source and hook that up to our collection view so you can see the data on the screen. So in our view here, we're going to say view dot data source is equal to self. Now there is another delegate or another property you can use to basically hook up a collection view cell, and that is a delegate. So if I say delegate, but the delegate is for actions on the collection view, whilst the data source is the data that you provide to it. Now we're not performing any actions on this, so we don't need it. But what we can do here, if we wanted to, is we could actually just go to the class here. So if I was to go to UI collection view data source, and I can basically see all of the functions that are available to me when using the data source. And if I was to just search for UI collection view delegate, I can now see all the delegate functions that I have available to me that I can use as well. So if you need to use something for a specific use case that you kind of need, like if someone's like, swiping on the cell, then you might want to check these out. But what we want to do now is actually set up our data source, because we have our error here telling us that our view controller doesn't have a data source. So in order to do that, we need to create an extension on our people view. controller. And we're going to make it use the type UI collection view data source like so. And now you should see that the error goes away, but you'll now get a new error saying that you've not implemented the protocols for this data source. So these are two protocols that you must provide implementations for to show, you know, your data on the screen. So the first one here is number of items in section, and that's just the number of items that you want to show on the screen. And the next one is the cell. So this is the cell that you want to show on the screen. Now it's worth noting, now what we want to do is actually use our view model, and this is where the link comes between our view model and our view controller. So the way this is going to work now is we're going to create an instance of our view model so that we can basically get the number of items that we may want to show onto the screen. So let's just create an instance of that at the top here. So we're just going to say private let VM for view model, and that's going to be people view model like so. And the number of items that we want to show in a section here is actually going to be the number of people that we have within our view model. So we're going to say VM dot people, which I've marked off. So if we go into our people view model, we actually don't want this to be private var. We want this to be private set var, because we still want to access it. We just don't want to be able to change it from outside the scope. So let's go back here. And we're going to say people dot count. So this is going to return the number of people in that collection. Cool. So when our view loads, we actually want to call our function to get our users. So after our setup, we actually want to say vm.get users so we can trigger that. Cool. So what we want to do in here is we want to create the cell that we created before and display that within our list. So let's just say here, let cell. And in order to create a cell, you need to do collection view. So you can use CV if you wanted to. But in here, I'm just going to use the collection view that gets passed through the function because it's the same thing. And we can just say, hey, DQ reusable cell. Now, it's really important that you use the DQ reusable cell, because if you create a new cell every single time without it being reusable, your app's going to really start to slow down. So in here, we're going to use our identifier. And then for our index path, that's just going to be the index path of our data model. So what's going on there is that it's actually going to loop through, you know, the number. So the number we provided here is 5, for example. It's going to count from 0 to 5, and then that's going to be the index path of our collection. So we can start to map our collection to our, you know, model. So in here, we also need to make sure that we cast it to be the type of our collection view cell, which is person collection view cell. And then we simply just want to return. Cool. So the most important thing here is that we need to make sure that we use our DQ reusable cell, because we don't want to be drawing any views on the screen that we don't need to. And the next thing we need to do is we need to use our index path here so we can access, you know, the cell at that index path and add it onto the screen. And we cast it as the type as well so we can return it. Cool. So now let's actually just run this and see what happens. And when you run it, you'll see that you see nothing on the screen. So the reason why you don't see anything on the screen is because, like I said before, in Swift UI, you would bind to some kind of state. That doesn't exist here. So you actually need to explicitly tell the view to basically update when this is finished to, you know, refresh the collection view. And we can do that by using a delegate. So delegates allow us to basically communicate between objects and delegate tasks, like the name implies. So we're actually going to create a delegate so we can communicate from our view model to our view controller that, hey, I finished, you should now refresh, or hey, I finished, there's an error, I need you to handle this. So let's go into our view model. And in order to create a delegate, you need to create a protocol. So we're going to create a protocol at the top here. And we're just going to call this people view model delegate. and it's going to be of type any object. Now, when I create my protocols, I like it to be the view model name and it end in delegate. Now, some people have different naming construction, different naming conventions, but I prefer just using this. Now, this is actually going to have two functions that is going to delegate an action to our view controller. And the first function is telling us when it did finish. And we don't want to pass anything into the parameters. So we're just going to leave that like so. And then the next one is going to be did fail. But this time we're actually going to pass through our error like so. So with the naming of these functions, I hope you're starting to see a pattern here that it's like did and then the action. So did finish or did load or did refresh or whatever it may be. So now we have our delegate, defined here with our protocol. We need to create a property within our view model to help us communicate back to our view that this action has occurred. In order to do that, we're going to create a property here. Now, because we're working with delegates, we need to make sure that we mark this property as weak. So the reason why we mark this as weak is because we don't want to create a retain cycle. I'm not going to get into too much, detail in this video, but essentially just make sure your protocol is marked with the any object. So it's important that you have it marked with this and you have your delegate as an optional and it's a weak variable. Cool. So now within our task, we can now call our delegate to communicate that this has happened. So after our people, we're just going to say self dot did finish like so, and then rather than us print into the console, we're going to say self dot delegate dot did fail, and then the error is what we'll go pass through here, which is the error. Cool. So now we have a way to communicate back to our view that something has gone wrong. I'm just going to use the question mark here. Cool. So now let's go into our view controller, and where we have our setup function, after our setup, we're just going to say view model.delegate is equal to self. And we should get an error saying that we've not implemented our protocol like so. So above or below here, I should say, let's create an extension on our people view controller. And it's going to be of type people view model delegate. And now this is going to implement those functions that we specified before. Like so. Cool. So now we have a did finish and now we have a did fail. So in our did fail, we're simply just going to print the error. And in our did finish, we're going to say that we want to refresh our collection view. And in order to do that, there's a function on collection view called reload data, which helps you reload the entire collection view. Now, if you want to reload a specific part, you'd have to basically pass in the item path with reload items, but we're not going to do that in this video. So let's just run this now and see what happens. And as you can see, we're getting there, but we still have another issue. And if we just look at our console, the issue that we have here is that we're actually updating our UI on a background thread, which is a big no-no. And now we have our crash. So how do we resolve this? Well, if you go into your view model and you actually click on the warning, you'll see here that we're basically calling reload data on a, background thread, which we don't want to be doing. So the problem lies in our view model. So if you go into your view model here, you'll see here that we're actually executing our code to basically, fetch our data from a service, but this code is actually run on a background thread. So how do we fix this? Well, all we simply need to do is just mark our function with the main actor annotation. And what this will ensure is that any UI updates that we do get placed onto the main thread, but any kind of processing on, in terms of fetching data is still on the background thread. So let's run this again. And ta-da, we now see our items in our list coming back from our service. So you can see here that I can scroll through and see our, data. But if you look at this, it's actually using static data that we defined within our collection view cell here. So in our person view, we've just basically hard coded the name label to be Billy Bob and the email to be billybob@gmail.com. What about if I want to use the actual data from the service? Well, what we need to do is actually access the data using the index path and then set this within our cell. So let's do that now. So the first thing I'm going to do is I'm actually going to create a function within this person view that allows me to update the label for the name and the email. So let's just scroll down here and we're going to create a new function called set. And we're going to call the first parameter name, which is going to be of type string. And then we're going to have another one called email, so we can set our email. So within this function, we just simply need to set those title properties. So we can just say name label dot text is equal to name, and then email label dot text is equal to email, like so. Cool. So now we have a way to set our person view from within here. Cool. So in our collection view cell, we actually need to basically pass through our data from our view model into this collection view cell, and we can do that by simply just creating a property called item, and this is going to be of type person response, like so. Cool. Now I'm just going to mark this as optional to safeguard it. And then within it, we're also going to use the did set. So what's going to happen is that whenever we assign a value to this item, which we'll do in our view controller, this will trigger. So just to show you that, if I was just to print out item like so, and let's go into our view controller. Within our cell for item, we now need to basically access that item and pass it into our cell. And we can do that by just using the index path, like I said before. So we're going to say let item is equal to view model dot people. We're going to access it like we would access an item in an array. And we're going to say index path dot item, like so. So after our cell's created, we can now just say cell dot item is equal to item, like so. Now I could have done all of this on one line, but just so it's clearer for you to see, I've broke it up into lines so it's more readable. So let's just run this and see what happens. Now I don't expect the UI to update, but as you can see, it's actually printing out each one of the items that was set within this property here. So now we have access to the email, first name and last name within this did set, which is what we want. So within here, we're now going to use those properties. So because this is an optional, we have to unwrap it. So we're just going to use a guard here. It's equal to item dot first name, and then we're just going to say let last name is equal to item dot last name, and then the email okay, cool, and then we'll just return like so. And then here we can now call our view dot set, and then we'll set the name using our first name. And then space, and then use our last name, and then pass in our email like so. Cool. So now we was to run this, you can now see that the data on the screen is matching the data that's coming back from the service. So it's not hard coded to Billy Bob anymore. We're now passing the data and updating our UI, which is perfect. So we have a few final things that we need to do before we wrap up this video. And the next thing we want to do is we actually want to delegate out of our collection view cell to our view controller. So whenever someone taps on subscribe, it loads up a link. So let's do that now. So let's just create a new delegate. I'm just going to call this again, person collection view cell delegate, and it's going to be any object. And then the function is going to be called did tap subscribe. Like so. And then within our collection view cell, we need to create that link between our view and our collection view. So we're going to say weak var delegate, and it's going to be person collection view cell delegate like so. And then now within our closure, we can say delegate dot did tap subscribe to, trigger that action. So within here, we're going to just mark this as weak self. And I'm going to just go say self dot delegate like so. Cool. So now we can actually have that link between our collection view and our view controller. So let's go into our people view controller here. And then here, we're going to say cell dot delegate is equal to self. So a habit that I have is I like to set my delegate first and then set my item afterwards, so that the item setup is done, after we assign it. So in here, we should now get an error saying that we're not using our delegate, which is right. So after our people view model delegate, we're now going to create another one called people view controller. Well, it's going to be person collection view cell delegate, and then now it should complain saying that we need to implement our function. So now we have our subscribe like so. Cool. So one thing you'll see now is that we actually have all of our delegates basically broken up into different extensions. And I'll be honest with you, you don't need to do what I'm doing here. You actually could just put all your delegates here on your view controller, but I personally think that's a bit messy. So I like to separate them out so I can see each isolated delegate and the implementations within them. So this is just a lot cleaner for me, personal preference. So within our did tap to subscribe, what we actually want to do now is actually open up some kind of like link. So we want to present a view on top of what we have now. And we can do that by using an SF Safari view controller. And what that basically is just a view controller that just has Safari baked into it. Now, in order to do that, we're going to need to import the Safari services like so. And then we're going to create a URL that we pass into this view controller. So the URL I'm going to use is just my YouTube channel. And we'll force unwrap that. And then now we will create the Safari view controller. So we're just going to say VC is equal to SF Safari view controller. And you can see that you have an option to pass in the URL, which is what we want to do. Perfect. And then now on our view controller, in order to present a view, we actually have a function called present. So we're going to say self.present. And you'll see here, view controller to present. So we want this to be VC, and we do want this to be animated like so. Cool. So let's just run this and see what happens. And if you're wondering what I'm hitting to just run this, it's Command R. So when this launches, all right, cool. So now if I tap on subscribe, you'll see that it pushes to the view controller and navigates to YouTube. So let's just select all these cookies and get rid of that. And you'll see now that we can see the Tons Dev YouTube channel on the Safari view controller, which is what we want. But to be honest with you, I don't really want it to push to a screen. I actually want it to basically present it from the bottom like a form sheet, like it would do in SwiftUI. Now, in order to do that, we have to change the modal presentation style on the view controller that we want to present. So in our case, that would be this VC property that's holding our SF Safari view controller. So if we go to VC, you'll see there's a property called modal presentation style, and that's what we want to change because we want to change the way it's presented. So we can say dot, and then we want that to be form sheet like so. So if I run this again, you'll see that we now, when we tap on this button, we now get a form sheet come up from the bottom showing me the Tons Dev YouTube channel, which is exactly what we want. And now we can hit done to dismiss it. So with this SF Safari view controller, one thing you'll realize is that you get the functionality that you would get with Safari for free. So I can share stuff with the share. If I was to tap on a link here, I'm going to try and choose a video that's not too annoying. So if I was to tap on a link here, so you can see that we have the back button, and I can actually tap on this to go into Safari as well on the actual, device, as you can see here. So cool. And I can tap back to go back into our application. So it's a really nice way to basically get Safari in your apps for free, which is great. Cool. Cool. So now that we've done that, we've got pretty much the core functionality of our application sorted. But the next thing I want to do is I actually want to add a title onto the top here, because at the very start, and I know it's been a lot of chapters, but at the very start, I actually mentioned that you can wrap this within a container, which is a UI navigation controller. Well, with a UI navigation controller, that's how you actually set your titles on your views. So within our setup function within here, what we actually want to do is actually customize our title and show that. So let's just set a title here. I'm gonna go say self.navigation_item.title. I'm just gonna call this people. So if I run this now using Command R, you'll see that we actually have the people title at the top of our view controller. But what I actually want is the, the large title that you will get in SwiftUI, for free. Now, in order to do that, we'd have to set the navigation bar and tell it to use that. So we can do that by saying self.navigation_controller.navigation_bar. And there's a property called prefers large titles, and we have to set this to true. And by setting this to true, we now get the large title, which you'll see in a second. Cool. So now this looks more like what we would build in SwiftUI. Cool. So now we have our whole application here, and I hope you've learned a lot about, how you can basically build an app in UIKit in this crash course. Now, I know this was a lot, and you can see that building an application in UIKit does take a lot more time compared to SwiftUI, but there's still a lot of companies that do use UIKit, and it's good to know the fundamentals that I'm teaching you here. So if you need to, rewatch this course over and over again until you feel comfortable. And when you understand these core, basics, then I feel like you have a good understanding of UIKit. So if you enjoyed my teaching style, I actually do have courses on my website, which I will link down below. It's in the description box to my website, and also you should see on the screen here as well. Also as well, if you find my content useful, you can actually donate using the thanks button on YouTube, or by buying me a coffee at ko-fi.com. Or if you just want to show some support for free, I'd really appreciate it if you share this video, if you comment, like, subscribe, and hit the notification bell to get updates for whenever I release a new video. That's everything from me. I'll catch you on a bit. Deuces.